Introduction to integers. Integers consist of positive natural numbers, negative natural numbers, and the number 0. So what we're going to use a number line to demonstrate integers. You can also think of a thermometer if you want to. Sometimes your own financial situation can help you understand integers. But suppose we have a 0 in the middle of our number line, and numbers to the right will be positive. 1, 2, 3, so on, so on, so on, so on. If you go to the left of 0 or below 0, those are negative values. And so we're going to use this number line to graph these 4 numbers. So let's make a number line. I'm just going to place a 0 right here because most of these numbers, yeah, I'll put it right in the middle. That'd be a 0. So if I count by ones on both sides, that will help me to graph the following 3 numbers. So a negative 3 would be, since the negative is to the left of 0, and by the way, all negatives and positives they're just direction on a number line. So negative means to the left, so we're going to go left 3 of 0. 1, 2, 3. So there's a negative 3. We're going to circle, put a little dot there, representing that that's where the negative 3 is. 0 is right there. Negative 7 will be 1, 2, 3, 4, 5, 6, 7. And then positive 7 will be to the right of 0, because when we go to the right, that's positive. 1, 2, 3, 4, 5, 6, 7. And that's how you use the number line to graph. Now we're also going to use the number line later on to help us with lots of other questions. So just be aware, this is kind of a big deal. Now let's do some problems involving order. That's less than because it points to the left, greater than because it points to the right, and equals. Let's do some examples. How do 7 and negative 8 relate? Well, 7 on a number line would be way over here, and negative 8 would be way over here. Since 7 is to the right of negative 8, we know we have a great right shark, it's greater than. Or in other words, the mouth eats the bigger number. How about these two? How about negative 11 compared to negative 6? Now negative 11 will be way over here, and negative 6 will be about right here. And since negative 11 is to the left of negative 6, it's a less than. Also, if you just think about it in terms of money, who has more money? Kind of a weird way to think of it, because both of these are in the hole. If you have 11 in the hole, or who has more money? The person that owes 11 or the person that owes 6? The person that owes 11 has less money because they owe more. They don't have near as much as the person does that only owes 6. So negative 11 is less than negative 6. And this first section is just a preliminary section showing you to get you accustomed to to how negative numbers can be applied to different types of problems. And here's a big application: absolute value. Anytime you see the words absolute value, it's a definition. The definition is the distance from 0 on a number line. Distance can never be negative. If you take 2 steps forward and 3 steps back, you still went a positive direction. In fact, you took 5 total steps. If you drive backwards in your car, your odometer doesn't go backwards, it doesn't go the negative direction. So, absolute value, distance. Think of it as a positive distance, because the distance is always positive. Anytime you see the double bars, that represents absolute value. So keep that in mind. And furthermore, when we do the order of operations, PEMDAS, the P represents parentheses, brackets, braces, and now it also represents bars. So we will do what's inside the bars before we do anything else if it's an order of operation problem. So here's an example. When you read this, you read it as the absolute value of 3. What it's asking you is how far away is 3 from 0 on a number line. And if you think about it, if you draw a number line, here's the 0. How far is 3 away? 1, 2, 3. So the absolute value of 3 is 3. If I ask you this question, what it's asking is how far away is negative 4 from 0 on a number line? Or the distance negative 4 is from 0. So So here's a 0, negative 4 is to the left of it. How far away is 0 from negative 4, or negative 4 from 0? It doesn't matter which way you go. 1, 2, 3, 4. It's 4 places away, so it's 4. Absolute value of negative 4 is 4. Some people think the answer is always the opposite. No. Because if you look at here, the opposite of 3 would be a negative 3. It's not the opposite, it's the distance. Distance is always positive. Keep that in mind. So when you see these questions, absolute value of 7, how far away is 7 from 0 on the number line? Well, that's 7 units away. How far away is negative 8 on a number line? How far away is negative 8 from 0 on a number line? It's 8 away. How far away is 0 from itself? It's not, because it's right there. So we didn't move. It stayed at 0, so it's 0 places away. So keep that in mind and be aware of that. And now, let's talk about the word opposite. If you look at a number line, and we look at 2 places to the right, and if I were to ask you, what's the opposite of 2? What I'm really asking you is, what's the number that's 2 away from 0, but it's on the other side of 0? And that number will be negative 2. So when you see something like this, negative 2, it also means the same as opposite of 2. And sometimes you want to think of it that way. So here we go. What's the opposite of 4? Well, what number is 4 units away from 0 but on the other side? A negative 4. What's the opposite of negative 3? Same question, but it's on the other side of 0. So if negative 3 is over here, then the opposite would be over there, which is positive 3. That's all that question is. That's all the word opposite means. So, this notation. Negative can also mean opposite. So just be aware of that. Negative also means opposite. And if I ask you what's the opposite of 0, you would say 0, because 0 is neither positive nor negative. So let's do a few examples. Now, before we do a few examples, when you read this is like asking, this negative on the outside is like asking the opposite of negative A. And the opposite of negative A would be positive A. Now, for future references, a negative and a negative becomes a positive when you multiply. Because if you see 2 signs separated by parentheses, you can think of it as multiplication also. But for right now, we're going to think of it as the opposite of a negative. The opposite of a negative is a positive. So let's find these values. This is asking the opposite of negative 2. What's the opposite of negative 2? Positive 2. Now on this one, like I was saying before with the order of operations, you can't do anything until you do the absolute values first. So what's the absolute value of 3? That's what we're going to do first. Just this part right here. Absolute value of 3 is 3. That minus sign's on the outside, so it just comes down for the ride. I call it a scrub because it's just hanging out. This one, do the absolute value first. We're like ignoring that minus on the outside, and we're going to do this part first. What's the absolute value of negative 5? And you would say 5. That negative comes down for the ride. Can't do anything with it. Now, so this example, evaluate. Once again, evaluate just means to substitute and simplify by the order of operations. So when I do this, anytime I do evaluations, almost always I use an empty parentheses. X is now a negative 2. That's why I'm going to put inside the empty parentheses. Once again, we got to do the bars first. Before we do the bars, we got to do what's inside. What's the opposite of a negative 2? Or what's a negative times a negative 2? And you would say positive 2. Now we got to do the absolute value. Absolute value of 2 is 2, and this negative sign comes down. Do all the work involving the absolute value signs first, absolute value bars first, and then you do anything on the outside. Just keep that in mind.